Thank you, Nadim. Also, I would like to thank Pier Paolo and Raquel for the first presentation. So my talk will cover the third pillar of our today webinar, the three codes webinar. So the third pillar is about the co-decision. So I will present some result of our OurMED project with title Sustainable Water Storage and Distribution of the MED region, funded by the PRIMA program, where I am the coordinator. So we are on the midterm part of the project, and our project has been funded in the call of 2022. So our vision or our ultimate goal in our OurMED project is to make the transition from fragmented monosectoral water management to more equitable and multi-sectoral management that addresses simultaneously the needs of different user and stakeholder, however, also benefiting from the capability of the different water body, like surface water, reservoirs, groundwater storage. So as you see on the left hand picture, so traditionally the water management has been tackled as monosectorial, where the domestic use very active on the headwater where we have enough water and we have reservoirs. However, agriculture is separated and not considering often the ecosystem needs on the downstream part of the basin, even though the river basin is integrative and interconnected system. So our idea to move on from that to more comprehensive and multi-sectoral water management, where we can benefit from the local but scientific knowledge, the advanced technology, advanced and innovative tools like modeling, all together will be embedded on digital twin system, where we can enhance the co-decision capability of different users in terms of thematic maps, alarm notification, risk mapping, and also showing them where they are from their ecological target. So to implement our project, we, as a team, we are 15 partners from 10 countries around the Mediterranean, and our work has been clustered in 8 work packages interconnected, starting from demo site characterization, covering the stakeholder engagement governance, to the co-design multi-sectoral management pathways. Also NBS, where we can implement, how we can co-design them, how much we can benefit from technology in work page 6. Also, we are considering the replicability and upscaling of solution in larger scale, but also in work package 8, we are always considering how we can disseminate, communicate our result to wider audience. So to implement, we have 8+1, so we call them 8+1, so 8 local demo sites, well spread in both shores of the Mediterranean, reflecting different water management problems. However, also this +1 is a regional Mediterranean scale, where we are thinking that the MED as a regional scale deserves to be considered as additional demo site, where we have to consider in terms of replicability, upscaling, but also policy alignment and policy recommendation. So mainly my talk today will focus on the co-decision aspect, where one of the output of our MED project to develop a digital twin system or water information system, which kind of continuously replication of real system behavior in virtual model, which will serve as a basis for experimentation, which we called, which here the co-decision capacity or capability. However, to develop that, we need constantly paired system with a physical world. So we have to mimic as much as we can the natural processes. So we need intensive calibration and validation to behave like real system. So we need numerical model, monitoring analytics, harmonized on very centric data and standard way. However, this effort should not be like one-step effort. So it should be a live effort where continuously we have to improve our monitoring, analysis, model simulation, prediction, but also revisit our ecological target and our priority as we are living on rapidly changing climate condition. So in brief here, with our partner Idrika from Spain, so the design of this early warning system or digital twin will benefit from historical knowledge, historical data, but also climate forcing. We will synchronize it with weather forecasting, hydrological model, but also considering and co-designing this with local stakeholder, considering their needs, expectation, but also their ecological threshold and ecological limits, and how they would like to receive the alert. And at the end will be user roles and user confluence developed, where stakeholder continuously can in real time see the system functioning, and they can do the intervention in short time. However, to develop this system, we need data. So we need high resolution monitoring. So we need to explore this kind of new wave of technological advancement and high resolution monitoring. For instance, here I am showing to you the monitoring of the same parameter on the same location and the body catchment in Germany. Historically has been measured each 2 weeks and monthly nitrate concentration. And in 2010, we started high resolution monitoring, and completely we are monitoring another system. So it seems we are in terms of minima, maxima, but also in terms of trends. But this kind of technology, sometimes community, they found them a little bit expensive. And also we are exploring other cost-effective solution and alternatives, where we are developing smart, low-cost or cost-effective camera system, where we can monitor turbidity and chlorophyll A with University of Napoli. And our preliminary results are promising, where we found nice correlation between what the in-water sensor measuring with the reflectance of RGB camera. Also, I think this kind of co-decision, we should be expected to be flexible enough to deal with kind of emerging problem which suddenly happen. The case here in the sudden brownification on the Albufera lake in Spain and Valencia, which was which one of our demo site. And the idea, so we were curious at the time how we can deliver maybe evidence and monitoring to this kind of sudden cyanobacteria blooms. And our partner AgroInsider from Portugal developed a nice monitoring, reporting, and verification tool, benefiting from a smart AG application, where they can deliver a kind of notification and alert using Sentinel-2 images to the stakeholder as reflected on this app. Another pillar also very important for digital twin or water information system is the modeling. So we need detailed enough, comprehensive model, but also coupled model, because we are dealing with multi-sectoral water management, benefiting from the different water bodies. So we need good access on the discharge, for instance, groundwater level, but also the water quality. And here we are exploring the capacity of coupling model together to have more output of the model, where different case stakeholder can see which parameter they are interested on, and they can take their decision. For instance, the drought condition experienced in the body catchment in Germany, I think was our learning space, because we have a real scenario in the drought system where we lost about 70% of the Harz forest on the last 6 years. And here we coupled the model in terms of stream flow, nitrate concentration of the river, but also groundwater level, which can, of modeling capability, will be integrated with the digital twin system to have fair and equitable decision. So here I would like to thank all our partners, and we'll be happy to answer some of your questions. Thank you.